The function f is defined by f of x as 8x plus 5 over 2x plus 3 for values of x greater than negative 3 over 2. We want to find the inverse of f, 3 over 2. There's a couple of different ways you could do this. One way is to actually find the inverse function. So we could say y is 8x plus 5 over 2x plus 3. Then interchange x and y in the normal way when we're finding inverse functions. Now we want to make y the subject. So if we bring this up to the other side, we get 2xy plus 3x is equal to 8y plus 5. So 2xy minus 8y is equal to 5 take away 3x. So y, 2x take away 8 is 5 minus 3x, giving us y is 5 minus 3x over 2x take away 8. And now we have the inverse function. We can substitute 3 over 2 into that. So you've got 5 take away 3 times 3 over 2 is 9 over 2, divided by 2 times 3 over 2 is 3, so that will be 3 take away 8. So that is going to give me a half divided by negative 5, which is negative 1/10. So that's certainly one way of doing it, but it's quite a bit of work. Is there a better way of doing it? Well, yes, there is, but you may not have spotted it. So there's always that way that we did first if you don't spot this. But let's suppose we've got two sets like this, and the function f goes this way, and therefore the inverse function goes the other way. Now, we wanted to know what the value of the inverse of 3 over 2 was. So inputting 3 over 2 into the inverse function. That's going to give us a value x back here. But that value of x put into f is going to give us 3 over 2 over here. So we could just do 8x plus 5 over 2x plus 3 equals 3 over 2, and solving for that will give us the value of x here. So that gives me 16x plus 10 is equal to 6x plus 9, and that's going to give me 10x is equal to negative 1, so x is negative 1/10. So if you spot that, there's a bit less work involved. Anyway, let's move on and look at part B. We want to show that f of x can be written in the form a plus b over 2x plus 3, where a and b are constants that we need to find. So we have 8x plus 5 over 2x plus 3 can be written in the form a plus b over 2x plus 3. So 8x plus 5 over 2x plus 3 is a times 2x plus 3 plus b all over 2x plus 3. And then we can get rid of the fractions and say, well, 8x plus 5 is a 2x plus 3 plus b. So 8x plus 5 is 2ax plus 3a plus b. Now, if we just compare the x's, like so, comparing the x's, gives us 2a is equal to 8, which gives me a is equal to 4. If we then compare the constants, 3a plus b is equal to 5, but we know that a is 4. So 12 plus b is equal to 5, giving us that b is equal to negative 7. So in other words, we can write this in the form 4 take away 7 over 2x plus 3. And we're going to use that a bit later on. So we now have a second function g. 16 minus x squared, defined just for x's between 0 and 4. We want to state the range of the inverse function. That takes us back to that diagram we had at the start. If this is G, and this is the inverse of G, then for G, this one is the domain, this one is the range, which means this is the domain and this is the range. So the range of the inverse is the domain of the original function. So for C, we can just say G minus 1x is between 0 and 4. It's the same as the domain of the original function. And then in part D, we want to find the range of f of the inverse of G. So what we could do is take the inverse of G, which, since g of x is 16 minus x squared, so y is equal to 16 minus x squared, interchange x and y. That gives us y squared is 16 take away x, so y would be the square root of 16 minus x. And we do need the positive square root because of this. And so what we could do is take that inverse of G and substitute it into f, since we're taking f of. But it actually works better if we use the rearranged value for f that we used here. So in other words, our f of the inverse of G is going to be 4 take away 7 over 2 root 16 minus x plus 3. Now, to get the range, we need the min and the max. So those are going to be the extreme ends. And what we can do to get the minimum value of this is to make this second term as large as possible. To do that, we need to make the denominator as small as possible. To do that, we're going to want x equal to 16. So if we take x equal to 16, we are going to get 4 take away 7 over 3. So that is going to be 12 over 3 take away 7 over 3, giving us 5 over 3. At the other extreme, let's make the denominator here as big as possible. That's when x is equal to 0. If we do that, that's going to be 7 over, so the square root of 16 is 4 times 2, that's 8. So that's going to be 7 over 8 plus 3, which is 7 over 11. So that is going to be 44 over 11, take away 7 over 11. And that is going to be 37 over 11. So if we think about that, this value, as we surmised, would be bigger than this one. And that tells us that our fg minus 1x is going to be sandwiched between 5 over 3 and 37 over 11.